Today, we are going to talk about parallelograms and how to find their area. By the end of class, you will be able to use our formula to find the area of parallelograms. So, to start, we are going to take a look at part one, which is area of rectangles or area of parallelograms. So it says that Elena and Tyler were finding the area of this parallelogram here. And Elena found it this way. She found that if she cut right at that angle here in a straight line at a 90-degree angle and took this little corner piece and shifted it, that she now had a rectangle. Okay, so she took this piece here and just slid it on over. Tyler did something similar, but he actually cut his rectangle more in the middle and still was able to shift this piece where he cut over to form a rectangle. So when we take these two opposite parallel sides and put them together, flip them on over, slide them on over, we get ourselves a rectangle. So finding the area of a rectangle is the same way we will find an area of a parallelogram. To find the area of a rectangle, we use area equals base times height. We multiply the base times the height. Sometimes it's said the length times the width. And we will do the same for parallelograms because essentially parallelograms, if we cut somewhere in that 90-degree angle and slide over that parallel side, we are able to create a rectangle. So let's go ahead and take a look here. So to find our area of parallelograms, our formula is A equals BH. So that would be area is equal to base, the base of the parallelogram, times, we know since these two letters are next to each other, these two variables are next to each other, that we multiply the base times the height of our figure, just like up here. So this base is the same as this base, and the height is at that 90-degree angle from our base. Okay, so a formula is a set of steps that we use. It's the system that we use to find area in this instance, but we will use a wide variety of formulas in math moving forward. Okay, so to do that, to use our formula, we have to follow 4 steps. Our first step is to always write down what our formula is. Okay, there are a couple of reasons for this. One reason that we write down our formula is because we have to memorize this. A equals BH. We must memorize that. And writing it down every time we find the area of a parallelogram will help that stay in our head. The other reason is because we need to find that base and that height, and this helps us remember which pieces we need and really helps us break down that parallelogram a little bit better. And we'll see an example of that in a little bit. Okay, so every single time you are finding the area of a parallelogram, you will write your formula. It should be at the top of every problem you use. Okay. Step number 2 is to label our figure. So then we can go into our parallelogram and say, okay, well, this is our base and this is our height, or wherever the base and the height might be. We want to do that because sometimes we'll have multiple measurements in our parallelogram. Again, I'll show you an example of that in a minute, but we need to make sure that we have the correct measurements. So we label our base and our height in this instance because that's what we need here, our base and our height. Step number 3 is to substitute measurements into our formula. So this is just like we've done before. B equals one number, H equals another number. These are our variables. We substitute in, and then lastly, we solve. When we solve, we will get an answer, an area, and we need to make sure that we use our units squared. All right, so I have an example down here for you. We started off writing out our formula here. So step number 1, we wrote our formula again. A equals base times height. You can't see the whole parallelogram. So here's our parallelogram. Before I even really look at it, I see, okay, I've got a parallelogram. What is my formula? A equals BH. A area equals base times height. All right, now step 2 labeled. This here is my base. It is one of my sides of my parallelogram. And the height meets my base at 90 degrees. So here is my height. Now I substitute in B equals 12. So I go ahead and rewrite 12 in for B. And H is 14. So I substitute that in. Now remember here, BH, that means we are multiplying because our variables are next to each other. Now, I can't keep these next to each other. I need a symbol of sorts. We cannot use the X. I typically, in these cases, use the parentheses, although a dot is fine as well. From here, I multiply together 12 times 14, and that gets me 168 meters squared. And that's my area. All right, let's try another example here. So we've got this parallelogram here, and we see that it's a parallelogram. We know the formula is A equals base times height. So I'm going to go ahead and write that down immediately. That is part of showing my work. I must have this written down for every problem. Step 2 is to label my base and my height. So my side is 20, that's my base, and 25 is my height, so I'm going to label that. Again, I need those labeled every single time. Step 3 is to substitute in. B equals 20. And then I multiply that with my H. H equals 25. Now I multiply. 20 times 25 is 500. I'm using meters. And because it is area, it's meters squared. Therefore, the area of this parallelogram is 500 meters squared. I've got one more example for you, and it takes us back to what I was talking about earlier. Sometimes you are going to have multiple measurements, and we need to determine which ones are the appropriate ones to use. So I start off by saying that this is a parallelogram and always write down my formula. From here, I label my base and my height. So I take a look here and I see that there are two sides of the shape that are labeled. So 19 inches is labeled and 13 and a half inches is labeled. But what we need to note is that although 19 could be a base, we don't have a matching height for 19. 13 and a half does not meet 19 at a right angle, so 19 does not get used right now. 13 and a half is our base, and it's met with a height of 18 inches. Now, I want you to remember that although we extended the base to be able to draw our height appropriately, we actually don't count that in the measurement. So sometimes they might write, you might have a little measurement here, and that's not part of it. We only use the actual shape, and then the height is from that little extension. All right. So now we've done step 2. We move to step 3, which is to substitute in. We've got 13 and a half being multiplied with 18. Remember, the number next to a parentheses with no operation means multiplication. So I multiply 13 and a half times 18, which is going to get me 243. I'm using inches, and because it's area, it is squared. And there you have it.